Hello everyone. So this is a question from JEE Mains 2026 8th April Shift 2. Given below are two statements. Statement 1. Due to increase in van der Waals forces, the order of boiling point is CH3 CH2 CH2I is more than CH3 CH2I, which is more than CH3I. Okay. Statement 2 is as para-dichlorobenzene is more symmetric, its melting point is higher than ortho-dichlorobenzene. However, its boiling point is lower than orthodichlorobenzene. Okay, and we have to determine which one is true, which one is false. The chapters involved is haloalkanes and haloarenes and chemical bonding. Okay, so the forces of attraction or repulsion existing among the particles, and those particles can be atoms or molecules of a substance other than the electrostatic forces and the covalent bonds, are called the intermolecular forces. Okay, so the forces of attraction or repulsion existing among the particles. These particles can be atoms or molecules of a substance other than the electrostatic forces and covalent bonds. They are known as intermolecular forces. Okay, and greater the intermolecular forces, higher is the boiling point, as we need to break, as you know, we have to give more heat to break those intermolecular forces. Okay, very important statement. Greater the intermolecular forces, higher is the BP, because we will have to need to give more heat to break those intermolecular forces. And at the boiling point, the heat absorbed by the substance is used to cut off the intermolecular forces to convert liquid into vapor, right? For example, if let's say we have water, so in the liquid state we will have water molecules and they will have intermolecular forces. This H will have partial positive charge. It will be having interactions with the oxygen of another water molecule, which will have, the oxygen will have partial negative charge. So these are the intermolecular forces of attraction, and at 100 degrees Celsius we break these bonds. Okay, so therefore more is the strength of these intermolecular forces, more is the boiling point. And similarly, greater the strength of intermolecular forces, higher is the melting point. Same thing applies to MP also. Greater the strength of intermolecular forces, higher is the MP. Okay, so there are many types of attractive forces, but dipole, dipole induced dipole, and dispersion forces, these are collectively called van der Waals forces. Okay, because this word is mentioned here, van der Waals forces. So the attractive forces like dipole, dipole, dipole induced dipole, and dispersion forces, that is London dispersion forces. So these are collectively known as van der Waals forces. Okay, and the intermolecular forces of attraction increase with the increase in size of molecules. Okay, very important. Intermolecular forces of attraction increase with increase in size of molecules. This is because since the size of the molecules increases, there are more sites of interaction. It can interact with more number of similar kind of molecules. Okay, for example, let's say we have a molecule of size this. So these are the sites where it can interact with other molecules. And let's say we have a bigger molecule of a bigger size. So therefore it can interact. These are the interacting sites. So it can interact with other molecules through these. So therefore, obviously, this guy will have stronger intermolecular forces compared to this guy. Okay. So therefore, for the same halogen atom, if we have the same halogen atom, boiling point increases with increase in the size of the alkyl group. Very important. Therefore, for the same halogen atom, boiling point increases with increase in the size of the alkyl group. Therefore, CH3, CH2, CH2I, that is propyl iodide, will have more BP than CH3, CH2I, which is ethyl iodide, and which will have more BP than CH3I, which is methyl iodide, because of their size. This has more size compared to this guy and compared to this guy. So therefore, statement 1 is correct. Okay. Now regarding statement 2, since para dichlorobenzene, that is this guy, is more symmetric than ortho dichlorobenzene, this is more symmetric than the ortho dichlorobenzene, that is this guy. Therefore, its molecules, that is this guy's molecules, pack closely in the crystal lattice, because we are talking about melting point. So we have to talk about the solid state. So this guy being more symmetric, pack closely in the crystal lattice. So I can, roughly show you their arrangement. So they can arrange in this fashion. This is one such arrangement where they are very packed, and also we don't have much spaces. Okay. So because of this the intermolecular forces of attraction are very, very strong, and hence this guy, that is the para isomer, melts at a higher temperature. So its melting point is 323 Kelvin than this guy, which melts at 256 Kelvin. Like the melting point, boiling points also depend on the dipole-dipole interactions, which is a type of van der Waals force, and the orthoisomer, that is orthodichlorobenzene, that is this guy, have higher dipole moment, obviously, because here these dipoles will have a resultant, because they have an angle, definite angle, and they will have a resultant. So they have higher dipole moment, and its dipole moment is mu is equal to 2.54 debye. Hence it is more polar. So this is more polar, and since it is more polar, it will have more van der Waals forces, more van der Waals forces, or you can say more intermolecular forces of attraction. Then the corresponding para isomer. The para isomer is our para dichlorobenzene, that is this guy. Here you can see the dipoles are exactly cancelling each other. So therefore the overall dipole moment is 0 debye, and therefore it is non-polar, and therefore it will have less van der Waals forces. Okay, and therefore the boiling point of orthodichlorobenzene, that is this guy, the value is 453 Kelvin, is more than para dichlorobenzene, that is this guy, and its value is 448 Kelvin. So therefore statement 2 is also correct. Therefore statement 1 is also true, and statement 2 is also true. Okay, thank you.